Hello again to all my friends. Mr. Benjamin here. Still a little sick, as you can hear, but I'm still alive and kicking. So the face is happy, but it's a very, mild, happy face. A little bit of a tear coming out.
He's got the man cold.
I've got the man cold.
Uh-oh. Worst kind of cold ever.
Wah. I gotta get rid of that to make space for...
Mrs. Podlipsky is here. Mrs. P. Okay. Very excited to get going on some videos for you guys. So this is our second video in Systems in Action. So today we're going to start talking about work and energy. I guess I should put a little happy face also because, as you guys know, I'm usually pretty happy. There you go.
So she's got the cheeks and everything.
There you go.
Does the P stand for punctuation? Mrs.
Yeah.
I forgot the dot there.
There we go.
Anyways. So learning goals for this video is to understand energy and describe the difference between kinetic and potential. Two very strange sounding words. Discuss the concept of work, not the Rihanna song, which is terrible, and calculate work with the formula of work equals force times distance. So we've got work and we've got energy. Work gives us energy, energy gives us work. No, we're going to talk about what each one is. Work is when a force, we talked about forces in the last video, causes an object to move. So if I take my little box here and I move it around, ooh, it's on here now, right? Oh, no, that was horrible. Let's go back. There we go. I'm going to move it somewhere else so it can still see it. Move it up here. No. It keeps disappearing. I'm going to stop doing that. Okay, anyways. Work is a force causing an object to move, while energy is the ability to apply force to an object. And this is measured in J, which stands for joules. I think that's how you spell joules. Maybe even E?
E-S.
E-S.
There you go. Perfect.
I apologize to, what's his name, James Joules?
James Joules.
James
Joules is the scientist that they have named the Joule after. Yes, James Joules.
He was filled with energy.
There we go. Okay, so I'm going to talk to you a bit about energy and the different types of energy. So energy can come in the form of kinetic or potential energy. So here we've got Katniss, wonderful Katniss. And so Katniss is using her bow and arrow, so this bow and arrow. So when the arrow is sitting inside of her bow and she's brought it all the way back and she's ready to release it on some of the people in the Hunger Games, it holds what we call potential energy. So it's got the potential to fly out, but it's not left yet, okay? So potential energy means it's stationary, but it has the potential to do something. Kinetic energy, kinetic means it's moving, okay? So it's got kinetic energy when something is moving. So for example, I'm sure you guys are all familiar with Miley Cyrus. I came in like a wrecking ball.
Stop it. My ears.
So if you are Miley Cyrus and you have a wrecking ball, so you've got your wrecking ball like this. Here's Miley Cyrus sitting on the wrecking ball. When it's up in the air and it's waiting to fall down, it's got potential energy. But when it's actually moving through the air, it's got kinetic energy. So it's actually moving. It's got kinetic energy.
It's
okay?
the potential to cause a lot of damage.
Yeah, so when it's waiting, it's got potential to cause a little bit of damage, or a lot of damage. So here's an example. We've got this guy who's up on top of a cliff of some sort, and he's ready to jump. So when he's up in the air and ready to jump, he has potential energy. As he falls or jumps down into the water, that potential energy is being converted into kinetic energy. So he's picking up speed and he's got kinetic energy because he's moving. Once he hits the water, he stops moving. So that kinetic energy is reduced down to essentially nothing. But in order to gain kinetic energy again, he's got to build back up and gain potential energy. So as he climbs back up to the top, that potential energy increases. And then if he jumps off again, he's able to start moving. So he's got potential energy. So potential energy is when they have the potential to move or as Mr. Benjamin said, even do damage. Okay? So here we've got this caveman. He's sitting on the ground. And there might be something that could fall on him. Do you see something that could fall on him?
I think there's something that can fall on him. Should we make it fall on him?
Sure.
This rock right here?
So that rock holds right now what kind of energy?
I think it's potential.
Yeah, because it's not moving, but it has the potential to fall. And so if it falls on the guy there, Poor man.
He's holding it up, though. He's pretty strong.
Yeah, so if he's holding it up, he's actually doing some work there too. But so this is specifically gravitational potential energy because that potential to fall is caused by gravity. So in the example with Katniss holding the bow and arrow, before that arrow flies, it does have potential energy, but it's from the bow. So this is gravitational potential energy. So that would be potential due to gravity, right? Because it's up in the air.
We're going to let him live for a little longer.
Yeah, let's let him live.
So if we want to calculate work, no, never mind. Work is equal to an object's force and distance. So work is measured in joules. Good friend James Joules over here, or Jim Joules, whoever his name was. Force in newtons, we talked about that. And distance in meters. Meters or kilometers? Meters is fine, right?
Meters.
Meters is fine.
Yeah.
So, should we do an example?
Sure.
All right, let's clear off some of this. I'm going to make my box again. And it has to be three-dimensional.
Why? Why? You take up so much more room when you do a three-dimensional shape.
Yes, but you can also hold more things in it.
I suppose.
So, if this box weighs, what, 30? Cancel. What are you doing? Stop. How much is it going to weigh?
Sure. It can weigh, I don't know.
25 kilograms.
Sure.
That's a heavy box. And I'm going to move this box that weighs 25 kilograms. We'll say there to there is, what? Oh, that ruined everything. Okay, we'll say I moved it 10 meters. 25 kilograms, 10 meters. Let's put these values into our formula. Work is equal to force times distance.
So you have to know the force, though. So even though it's a 25 kilogram box, in order for it to move 10 meters, you have to know what kind of force that you're pushing against it, right? So the 25 kilograms, the calculations that we were doing yesterday, that would tell you the force.
Based off of gravity. So 25 times force of gravity is 9.8 newtons per kilogram. Oh, it is, isn't it?
Yes.
And it gives us 245.
245
newtons. And our distance, 10 meters.
Okay, so if it's 245 newtons of force is going to allow you to move that box, the three-dimensional box, 10 meters, we can calculate the amount of work done. So remember, work is going to be measured in joules. This is the same unit as energy.
I just added that extra step in because I forgot it the first time.
There you go.
And our answer?
So 245 newtons times 10 meters.
2,450 joules. James Joules.
James
Beautiful.
Joules. Thank you, James Joules. So if
they're
you
not
wanted,
able to see that anyways.
you could put that into kilojoules, right? So you could go
Oh, we can convert it, that's right.
2.45 kilojoules. Because it's the metric system. So kilo means 1,000. So we just divide it by 1,000 to get 2.45 kilojoules of work.
Okay, we have to explain that for all of our American friends. They don't use the metric system.
That's right.
So why don't we try this? We're going to comment on this video with an example of kinetic or potential energy. Okay, we've given you at least 3, if not 4.
Yeah.
So there was the wrecking ball. That's right, I'm going to draw it.
We did Katniss and her arrow.
I call my dog Fatness. I'm going to show you a picture of Fatness. And what was our last example? While I find this picture.
We did Katniss and the arrow, so it was potential energy before it flew from the bow and then turned into kinetic energy. And then we had our caveman. Oh, there's Fatness.
Where's a good spot for him?
There you go.
That's Fatness.
Is that his actual name?
No, his name's Cujo.
No.
A.K.A. Cujo. He's really small, but he's really fat. It's kind of sad.
So give us an example of either kinetic or potential energy and comment on this video below. So my class, you're going to comment directly in Classroom, in Google Classroom.
My class, go ahead, comment on the video. And if you feel special, comment in Google Classroom as well. If you can somehow comment in Miss Podlipski's classroom, that'd be even better.
Well, they're going to hack in, are they?
Somehow. What do we say?
Thank you.
Thank you.
So we'll see you guys in class tomorrow where we're going to do some actual calculations and some work. Some work.
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 Bye now.
Bye.